Alrighty, so today we're talking about decentralized social media. We think this is a very relatable and exciting topic to express how blockchains can help drive social change. So first of all, what do we mean by decentralized social media? So today we're talking about a relatively new decentralized social media platform that's called Lens Protocol, which has been gaining a lot of traction lately. So Lens is a decentralized social media layer that anyone can build their own platform on top of. So it's basically quote unquote composable, which means if users aren't satisfied with the platform, they can move elsewhere without switching costs and basically maintain their existing social networks. We will expand on what this exactly means in future slides. There are other decentralized social media options that exist, but this one has seen some really great adoption, and we can access this data using the graph. And we also really like what they're building for reasons we will dive into in the next couple slides. So first of all, why do we even need this and why does it matter? What are the problems with the current platforms we rely on today?
Everyone knows Twitter, right? All over the place, now owned by Elon. And that's going to be interesting to see what that does. But what are the problems with Twitter that we know about, Ricky and Nihal? The users are there to be monetized, and they lock the users onto the platform to make sure that they can keep monetizing them for as long as possible. And they keep stuffing all the data about what all the users do into their own database, right? And that's part of what they want to sell to other marketing companies and so on, or use for their own purposes. But at the same time, there's an enormous risk to this business model. And Twitter has not figured out how to make money, which should make all the users nervous, because that means that data about them can be used for anything that will make money to make up for this in the future.
That's exactly right, Kai. And another risk here is that with all the data being in these kind of centralized databases, you also have really big targets for hackers.
And these databases know so much about us, right? About who we are, how we think, when we think it, and they can be used to manipulate us.
I was going to maybe make another point, tagging along what you said around the fact that this very past quarter, they lost almost $350 million. And to your point, like this kind of creates questions around what happens when a company like this has billions of dollars worth of user data and has this fiduciary responsibility towards the investors, but not the users themselves. So if we want to build a new solution which doesn't take advantage of its own users in the ways that we outlined here, it's really important to make sure there are actual sustainable business models to actually make it happen, right? So what would decentralized social media need to get right in order to not only create better systems, but also sustainable business models? So there's actually three different layers to this that we've outlined here. So one of them is where the data is actually written in a way which can be arbitrarily modified. So blockchains like Ethereum and Polygon perform this role, and they have sustainable models for verifying and storing accurate data. Then we have how the data can actually be accessed. So blockchain data can be really difficult to access, and this is the problem that the graph actually solves. And they also have a sustainable business model around that. Then we have platforms which actually maintain the websites to digest the data and make it available to the users to interact with. So this is the main thing we'll see a lot of growth around in terms of offsetting costs and being profitable while leaving all the power in the hands of the users. So next, let's talk about what these sustainable business models for these social media platforms could actually look like in this context. So one idea here is that a developer or company could recreate the Twitter and Facebook advertising business model. In this case, however, they could, for example, keep a portion of the revenue as profits, let's say 10%, and then redistribute the rest of it to the actual users themselves. Meaning users could specifically decide to opt into advertising to make a profit themselves, as well as the platform that's supporting that growth. So this creates a lot more healthy competition. Another platform, for example, could come along which only keeps, let's say, 8% of the profit, or another one could come along which allows users to be more in control of the ads they receive. Or yet another one could differentiate itself with a different social media algorithm for its newsfeed, improved user experiences, or any other number of ways. And as different platforms with different value propositions come along, these users can basically freely move to use different ones, or even use multiple ones to their liking. And if some platforms take advantage of the users and their data, they can basically just freely move to different ones.
But Ricky, owning all of Twitter means losing $1.5 billion a year. What does owning a platform where you only get to keep 10% of the profit yield you in losses a year?
That's a really good question. And I think this ties back to the innovation part. Having this kind of more competitive landscape is going to incentivize leaner operations and people solving this type of problem. But I do think that you could definitely run a profitable social media platform with all the money that flows in through advertising alone. And I also think that this is just one way of funding a platform. Anyone can build their own solution without real limitations to what they can build. And yeah, it just comes down to innovation.
So what are these, Ricky? Are these examples of Lens protocol application?
Yeah, so here I really wanted to clarify what we mean by composability. So in this context, it basically means you can share your one account and social network to interact with a variety of different platforms, which are built for different purposes. So here we have listed some decentralized alternatives to Twitter, YouTube, and LinkedIn, which is these links in order, which all already work great today. And the difference here is that they all leverage the same underlying social graph and connections, but they essentially present you that information in ways that are appropriate for the platform you're currently using. So now let's start diving into some data and visualizations. So all the data in these slides was pulled using the graph to easily and quickly get everything we needed. So we can look at some overall statistics like the growth in number of profiles over time, but there's really a lot of other places you can look at these kind of metrics. So we're actually going to focus on an analysis we did around where the content itself gets stored, because we think that's a really interesting topic. So more traditional blockchains like Ethereum and Polygon are really not a good solution for storing content like photos, videos, social media posts, or even full-on websites. Therefore, what happens is the transaction will post a link to the content itself instead, and that content is uploaded to decentralized storage solutions, or in some cases to centralized storage, which is really bad and defeats the purpose of everything. So this has actually been a really big problem for NFTs in particular, where users own an NFT, but the content itself becomes no longer accessible over time. And one really popular decentralized storage solution is called IPFS, which allows anyone in the world to store that content wherever they like. And as long as one copy of that content is made available by someone, then it can be accessed by the broader network. So posting to IPFS is free, but if the file isn't stored or made available by anyone, it becomes inaccessible. And because of that, a better solution is to post the content to a blockchain, which is specialized in storage, like Arweave, where users can pay once and have that content stored forever. And it also has incentives around storing that content versus you don't have any incentive to ever store content for IPFS and do that out of your own free will. So because of this, next we will look at where the content for the Lens protocol is actually being stored and whether we were able to successfully retrieve that in under half a second. So here we can see how many posts and comments are posted to IPFS versus Arweave versus the Favor API, which is centralized storage that's specific to one of the popular apps currently on Lens protocol. One thing that I found really interesting here is that Favor actually seems to have the vast majority of interactions being posts compared to comments. And this could actually be caused by the fact that they have a scoring concept, which is eventually going to be tied to a cryptocurrency token down the line. So the point of this is just to show there's kind of an even distribution among the usage of these three. So what percentage of the content were we able to access across these three solutions, being IPFS, Arweave, and the Favor API? So one thing that's important to note here is that the script we set had a timeout after half a second. So although the Favor API content was successfully collected over 95% of the time, the one that was not collected is actually a completely dead link. On the other hand, the content that is stored on Arweave was available 100% of the time, but it took more than half a second to retrieve. So we had to move on to other data to collect it within a reasonable amount of time. And that's why this bar is lower. On the other hand, you have IPFS, which was both really slow and pretty often we couldn't load that file at all. So really none of these solutions are optimal right now. I personally find that Arweave is the best because I haven't found any posts at all that couldn't be retrieved, but it still does leave room for improvement on the speed side of things, which can make it difficult to provide a high quality experience and do analysis on large amounts of data. But they are working on these types of things, and you can still do pretty reasonable things like cache the information or write it to your own faster centralized database.
So Ricky, this is a fantastic piece of research you did. Let's say they go from, what do they have now, 60,000 users to 60 million. How is this going to grow with that? Do you have any sense of that at all? Will it scale?
Yeah, so the difficulty here is you do have these different layers that all need to scale correctly in order for that to happen. So on the data storage side, you have Arweave, which will scale really well because there's going to be more incentive for the miners on that blockchain to provide more storage. So I'm pretty confident that would scale really well. And on the blockchain side of things, I think that's a bit trickier, but there's a lot of really good innovation happening in that space to increase the number of transactions per second. So I think that side could be a bit problematic in the short term, but we have a clear roadmap towards resolving that as well.
Very nice.
All right, so that's basically it. We did also do some pretty interesting sentiment analysis on the content which we were able to successfully retrieve, but we decided to cut it from this presentation in the interest of time and to focus on the content storage. As always, we do have a GitHub repository available for anyone to reproduce our analysis or extend it in any way they please, which includes our code for the sentiment analysis as well. And we may also have some separate follow-ups on this topic, so stay tuned for more. And yeah, we really recommend you to check out the Lens protocol and try it out. And another great platform in this space worth looking into is called Orbis, which is also linked here. Cool.
Oh, very cool. Good job, Ricky. I think we compressed that down quite a bit. Cool. Thanks, guys.
Yeah, thanks so much.